Luciano Chiang, and in this video I am going to show you how to build this jig to make finger joints. The good thing about this jig is that it's very simple to build, and it's very easy to make the finger joints, and we get finger joints such as the one that I'm showing right now. The interesting thing about this jig is that it's very simple to build and it's very easy to use. Usually, to make finger joints, you need a dado blade or you need a stack of blades. And this is very expensive, and a lot of low-cost table saws do not allow you to mount a dado blade because they are too wide. And because in the case that you want to make finger joints that are very wide, such as the one shown here, it would be very difficult to find the dado blade, and it would be very difficult to find a table saw that would allow you to mount such a thick dado blade. To build this jig, I used pieces of oak mounted on the miter sled in the way that I am showing here. The pieces are 1 inch by 5 inch planks, and it has a moving block that runs along a groove, and the position can be fixed using a 1/4 inch bolt with a wing nut. Now, the width of the nail has to be as close as possible as the width of the cut left by the saw blade. Here I cut one with my saw blade and left this groove, which measures slightly more than the nominal width of the saw blade. But the issue here is that the diameter of the nail has to be as close as possible to the width of this groove. If the diameter of the nail is not close to the width of the cut of the saw blade, then you will have problems, because either the teeth will be too wide and the finger joint will not match, or either the voids will be too wide and then the teeth will fit in loose. So that's why it's very important to have the nail as close as possible as the width of the groove. Now I am going to try to join these two pieces made of MDF in this way, in an angle of 90 degrees. For this, I am going to use this reference block, which is going to give me the width of the fingers. And I am going to set it up as so. First, I overlap the two parts and I give them the offset set by the width of the block, which is the width of the fingers that I want to have. Now I clamp safely, being careful that the reference block is flush with the lower piece that I am going to join. A better hold and safer is obtained by using a double clamp as shown. Now I am going to mark the first groove in the joint. This groove will serve as the reference for the rest of the groove in the joint, as you will see. But I need to mark them, being careful that the reference block is flush in one side to the upper piece. So then I will have these two parts, and I will cut the groove, the first groove that will serve as a reference. Now I have to set the height of the blade to the height of the fingers, which should match the width of these MDF pieces that are 9 millimeters thick. That's why I'm using one piece of MDF to set the height of the blade, as shown. Now I'm going to cut the first groove or reference groove using the marks, the pencil marks and the offset that I have in the overlapped planks. So for this I use as a stopping block the moving block in the jig, and so that allows me to maintain the position of the first cut in this case. I do this, I eyeball this because I find that this is enough, the precision is good enough for the results that are pursued. So this is the first cut, and I use the offset as a reference to make it. And now I'm going to make the second cut of the reference groove or first groove, for which I use the pencil mark that I have, and I use the moving block with the nail to keep the position of the cut safe. See, I do this by I use the pencil mark as a reference, and after I fix the moving block I can cut it, and then I go back towards the first cut and generate the first groove and reference groove of this finger joint. As you see, I generated the first groove, and this will be the reference for the second groove, and the nail will provide the limits to generate a copy of the first groove. So now that I've fixed the moving block, the sliding block of the jig, I can start cutting the second groove. Notice that the nail limits the travel of the cut because the nail is in the first groove. Now I will cut the last groove using the previous groove as the reference to limit the travel and width of the groove. Here it is finished, and let's see how the finger joint fits now. As you can see, it's quite acceptable. You might have to finish it up with a router later, but at this stage, it's quite acceptable, the results that we have. A final word about the use of this method is that you have to be very careful that some of these table saws, especially the low end and low cost, the more economical ones, they have a tendency to have the blade move upwards or downwards while cutting, and so after several minutes of cutting, you might have the blade that has moved maybe a few millimeters. So this might be acceptable for just ripping and cutting, but for finger joints, this is unacceptable because you would have fingers of different height.